I have just make it small remarks before for the vector table product. We have two vectors A, B, and C. One two vector table product. We change it to two. We having here we take the cross product of B and C, and we take vector A. So we have now two vectors, one A and another B. Now we can take it cross product. We take A cross B cross C. We can write this in terms of the scalar values. We having A dot C into B minus A dot B into C. We take the right hand side, I will take the left hand side, the result will be the same, the result will be the vector. So we apply this one on this example that we want to find the cross product A cross B cross C. I will try to make it by both ways, solution of this one. First I take the left hand side. Left hand side mean I want to find A cross B cross C by first finding B cross C and then with A. So I say here my B cross C is equal to I, J and K. Then I have B is minus 3, 1 and 0, C is 1, minus 2 and 4. So I take the cross product. I, the coefficient is 4I, then minus J will be minus 12, 0, minus become plus 12J, and then plus K. The plus K will be equal to minus plus 6 minus 1 is 5K. So this is my B cross C. Now I take here A cross B cross C. This means I have B cross C, and I use this vector B cross C to find this one. So I am having here B my I, J and K. Again I, J and definition of my cross product. Then the component of A. What's the component of A? Is 2, 0 and minus 1. The component of B cross C is 4, 12 and 5. Now I take here the solution of this one. Again I take the component of I, this will be 0, and here is minus become plus. I get here 12I, then minus J, here is 10, and then we having plus 4 is minus 14J, then with K is 24 minus 0 is plus 24K. So this is my left hand side. Now I take my right hand side. This is my left hand side. For my right hand side, I am having here, I find here the value A dot C. So my A dot C is equal to, I have vector A and C, this 2 into 1 is 2, 0 into minus 2 is 0, then we have minus 1 and 4 is minus 4, the result is minus 2. Then I need A dot B, so I write here A dot B, the dot product of A and B. This one is 2 into minus 3 is minus 6. Then I'm having a 0 into 1 is 0. Then here is minus 1 is 0 is 0. The result is minus 6. Now I can write here my final result. A dot C I multiply by B and A dot B I multiply by C. So I having here A cross B cross C is equal to having A dot C minus 2 multiplied by A. This minus 2 multiplied by B here is minus 2 into B is minus 3. I am having here 1 and 0. Then I am having minus sign, and I am having here A dot B, and A dot B is equal to what? Is minus C. Minus 1 become plus. Then I am having plus 6 into C. What C? This is my C. 1, minus 2 and 4. Now we multiply it and add it. We multiply here by minus 2. I get here 6 minus 2 and 0. 6 minus 2 and 0. Then we have plus sign, plus we are having here the result is equal to multiply by 6. We have 6 minus 12 and 24. 6 minus 12 and 24. Now we add these two and we get here the final result is equal to 6 plus 6 is 12. Minus 2 minus 12 is minus 14. And 0, 24 is 24. And that is the same. This is my solution here. This is my left hand side and this is my right hand side, and they are equal. So I can say here my A cross B cross C, we write here the left hand side taking the cross product is equal to A dot C into B minus A dot B into C. So this is the idea for that one, that we can apply our scalar vector table product, and apply it we get a vector, and these are details. We can use the dot product for finding the vector triple product, or we take the cross product to find the vector triple product. So we just, I'm giving you some information. We're having here the XYZ system, and along x-axis we have unit vector I, y-axis is unit vector j, and z-axis is unit vector k. We have this system of unit vector I, j, and k. So if we multiply I and j scalarly, when we say it's I dot j, so I dot j, because the angle between them is 90, is 0. And if we multiply j dot k, also this will be equal to 0. And we multiply k dot I, also this is equal to 0. Now when we take the cross product and I multiply I cross j, so what will get? I get a vector, unit vector normal to the plane containing I and j. And we're having here, if you expand it, we're having magnitude of I, magnitude of j, and then magnitude of k, magnitude of sine of theta, the sine of 90 degree between them, into unit vector, that's k. So we get here this is equal to 1 into 1 into 1 into k. So the result is equal to k. So I say I cross j is equal to k. Similar to this one, I am having here, these are 90 degree between them, they all are 90 degrees. K dot k cross j in the same plane we are having here. So what is the result? Result is equal to I, and we are having here, this is k, we're having here j cross k, because we are having the same direction we have to take, is anti-clockwise. And then we are having k dot I, k cross I is equal to j. If we are having this is clockwise, anti-clockwise, this is having this one here, this direction anti-clockwise. When we take the clockwise, then we are having here from j cross I is equal to minus k. When we change I and j, we get here minus sign. We are having here I cross k is minus j, and then k cross j is minus I. Now if we take here I cross I, then I cross I, this is number 3, we can see I cross I is equal to 0, because angle between them is sine 90 and sine 0, and sine 0 equal to 0. And we are having here j cross j is also equal to 0, and k cross k also equal to 0, because when two vectors are parallel, then the cross product is 0, and when two vectors are orthogonal, then dot product is 0. So these are the important points for you to note it. So please, you can find more examples in my notes and more problems for your practice in the notes. You can just go to the description and you'll find the notes there, and you can copy the notes and make more practice. I always advise my students that you have to solve the problems. If you solve the problem, you will master it. Just reading is not sufficient. If you solve the problem get the problem from the notes, also get the problem from the book. Each book of the calculus is having a lot of problems, very rich in the problems, also the applications there. So when you master this one, this is like the skills, this is like the tools, and that will help you a lot in learning the advanced level of your engineering courses, where you are going to apply all of these information. So please again, for science students, for engineering students, this is very important part of mathematics. You must master this one. You can master it by solving the problems. Please take the notes also from the description. Also take more example from the book and problem from the book and solve it and master it.